Class. Today we are looking at section 5.4, factoring trinomials with a leading coefficient other than 1. On page 332, it gives you some rules on factoring general trinomials using trial and error. A lot of you was taught that strategy in school to just do trial and error, but we're going to actually look at a method to help us factor out these trinomials. And it's called the master product method. It is called the master product method. The master product method also involves factor by grouping. So you need to be very comfortable with doing factor by grouping. Turn to page 336. I do want to add that there are so many different ways to factor trinomials. If you just do a little research on YouTube, you will see a lot of different ways. A way I used to do it was the slide and divide, but I was taught the bottoms up method. That's what it was called for me. The bottoms up method. It's a really great strategy as well. The only problem with that method is it can be lengthy, so you got to actually remember what to do next. The master product method is a little quicker, and I think it's a little simpler. So you all can just give me some feedback on what you think about using the master product method. I'm on page 336 looking at number 19. It says factor. We have 3a squared plus 7a plus 2. Again, your leading coefficient is 3, your degree is 2, your constant is positive 2, and this is a trinomial. Right here, my leading coefficient is a number other than 1 this time. So we're going to apply that master product method. So to apply the master product method, you need to know your vocabulary. The leading coefficient is 3 and the constant is 2. You multiply those two numbers together. So 3 times 2 is 6. The next thing I need to know is what will multiply to give me 6 and add to give me 7. Well, I know that 6 times 1 is 6 and 6 plus 1 is positive 7. So those are my two factors. After we find our two factors, we're going to do a rewrite. We have 3a squared. We're going to replace 7a with 6 and 1. I'm going to say plus 6a plus 1a and then plus 2. If you check your math, and you want to always go back and check your math to make sure it's right, just takes a few seconds. 3a squared, 6 plus 1 is 7a, and then plus 2. It's the same problem. Make sure it's the same problem before you keep moving. Now, I notice I got 1, 2, 3, 4 terms. I can use factor by grouping. Factor by grouping, I'm going to take the first two and find out GCF, which is 3a. Up and down, we're subtracting the exponents and we're doing division. That's what the rule is for dividing exponents. You subtract them. So 3a goes into 3a squared a times plus 3a goes into 6a 2 times. Take the next two. Follow that sign, which is plus. What's my GCF for 1a and 2? Well, the only thing I can use is 1. But you need to write something there, so it has to be 1. When I factor out a 1, I am left with a plus 2. Before you move forward, make sure the parentheses match. And they do, so I can keep moving. In the two groups, what is now my GCF? A plus 2. What is left over? 3a plus 1. And that is how we do the master product method. Just a few steps. But we are going to do just a few more examples to get the gist of it. But it's very easy. And that's all we have to do to the master product method. Let's try number 31. We have 16m squared minus 14m plus 3. So my first step is I want to multiply 16 times 3. I'm going to pull my calculator out for that. 16 times 3 will give me 48. Now, I need to find two factors that multiply to give me 48 still and add to give me 14. Well, I know that 6 times 8 will give me 14, but I want negative 14. So I need to write negative 6 minus 8 will give me negative 14. But make sure negative 6 times negative 8 is still positive 48. So everything still looks good. We're going to do our rewrite. I have 16m squared minus 8m minus 6m plus 3. Now, if you notice, I wrote negative 6 and negative 8, but when I set it up, I said negative 8 then minus 6. Okay, so does that matter? This should not matter. If I was to start off with negative 6m minus 8m, when I do my factor by grouping, it should still all turn out the same way. So it doesn't matter how you arrange these, they're going to come out the same way. But also another indicator is we have to remember that when we do factor by grouping, the parentheses must match. So long as those parentheses match, you're doing it correctly. So right here, don't be obsessed with how to line these up. Just put it in there and then do your factor by grouping and it'll all come out fine. Me, I just like to do the big number first and the little number second. So you'll see me doing mine that way. The first two, what is my GCF? It is 8m. 8m goes into 16m squared. 8 going to 16 twice. 2 minus 1 is m. Bring down that minus sign. 8m divided by 8m is 1. Same, S-A-M-E, divided by same equals 1. Follow that sign and be careful because it's subtraction. My GCF now is 3. 3 goes into 6m. 2m times a negative makes a positive. And 3 goes into 3 one time. My parentheses match. I'm doing it right. Factor out again. I have 2m minus 1. And what's left over is 8m minus 3. Does it matter how I write my parentheses? No. If I started off with 8m minus 3 and then 2m minus 1 second, it will still be right because it's multiplication. You have to think about elementary. 2 times 3 is 6, and 3 times 2 is still 6. It doesn't matter when you're adding and multiplying. Okay, let's try another one. We're only going to do a few. Let's look at number 51. 51, 2x squared plus 3xy plus y squared. So first of all, it's in standard form. We have, you start with the lowest exponent and then you start with the lowest, the smaller, you go in alphabetical order. I had to fix that. Go in alphabetical order, x and then y. And then the xy piece always goes in that middle. So when you see problems like this, this is your standard form. You keep it in alphabetical order. The x is first, the y is second, and then the xy, they come together in the middle. So I always say it look like a sunshine, even though it's not that. I say it starts like a smiley face. It starts up, comes down, then come back up again, even though this is also 2, if you count the exponents. But that's how I see it. Your coefficient and constant, in this case, will be 2 and 1. So you do have to pull the number out of this one. So don't worry about the y squared. Just pull the number out for the first and last term. So we have 2. Now, I had to multiply to get 2 and add to get 3. So 2 times 1 works. Let's do our rewrite. And you're going to be careful with this rewrite because you have to include xy in the middle part. I have 2x squared plus 2xy plus 1xy and then plus y squared again. So you do have to put the xy in the inside part, the outside inside part, because if you don't, it's not going to factor out correctly. Take the first 2 and find your GCF. It is 2x. So 2 minus 1 is just x, plus 2x goes into 2xy, y times. In my second part, what is my GCF? Plus y. So I'm left with x plus 2 minus 1 is y. My parentheses match, so we're going to keep going. My GCF is now x plus y. What is left over is 2x plus y. So let's try another one. Number 65. 65 is negative 26x plus 6x squared minus 20. Now, what is my problem with this one? Well, the problem here is it's not written in standard form, or another word, descending order, or another word, descending powers, but it's not in that order. I need to start with the base and the highest exponent. So we're going to start with 6x squared minus 26x minus 20. So now we do have it in standard form, so we can go ahead and go through our process. 6 times 20 is 120. I need to find two numbers that will multiply to give me 120 and subtract to give me 26. Well, you do have to think a little bit about this one because you have to go outside your 12 timetable. So you have to think about it a little bit. Knowing your divisibility rules helps you to break these down better and figure out what goes where. So if you can study over your divisibility rules, that will help you a lot. Also, you can do a factor tree and just rearrange those prime numbers around to find your two factors too. That helps also. So right here, I know 30 times 4 is 120. And I also know that negative 30 plus 4 gives me that negative 26 in the middle. So when we do our rewrite, I have 6x squared minus 30x plus 4x minus 20. And that works. So we're going to do our factor by grouping. My GCF here is 6x. Divide these two. I have x minus 6 goes into 30 5 times. Find your GCF for the last two terms. It's going to be plus 4. 4 goes into 4x one time. A negative times a positive makes negative 20. And then 4 goes into 20 5 times. Now, it's something I don't like. My signs don't match. So we need to see what's going on with this problem. Okay, so I see the mistake. That should be plus. So that's why I really stress to you all to follow that sign next. You see how it changes my problem when I don't follow it? And now it's right. So again, I want to stress to you, you must match the parentheses when you're doing factor by grouping. You must follow that sign to make sure that your grouping comes out correctly. So all these little key things I'm saying, you got to lock it in. Okay, now my GCF is now x minus 5. What is left over is 6x plus 4. Now, I see something else. So this is definitely a problem I'm not liking because I keep goofing up on it a little bit. But let's talk about it. But this is good because this helps you think about what you need to do too. But look at this trinomial. Does it have a GCF? It does. It has a GCF of 2. And the reason I know that because when I look at my final answer, can 6x plus 4 be factored again? It can be. So you do have options. You can do your GCF at the very beginning, or you need to make sure you do it at the very end. But you must factor out that GCF eventually. So right here, I'm going to just do it at the end. It's not a big deal. I can just factor out at the end as long as I catch it. So I'm going to factor out a 2. And I know 2 goes into 6x 3x times. Plus 2 goes in a 4 2 times, and then bring down the x minus 5. Remember what I said earlier. When you multiply, it doesn't matter how you arrange your multiplication. So we learned a lot of things today. We want to make sure that we follow that sign next. We want to make sure our parentheses match. We want to make sure that we identify if there's a GCF first before we start working with the different methods. Okay, so very, very important. So it's so important that you remember those different strategies. All right, let's try another one. We're going to talk about a perfect trinomial. We talked about a perfect square. A perfect square will have two terms, so it'll be a binomial. It has a minus sign in between, and when you factor it, they look like conjugates. They are conjugates. But a perfect trinomial is different. You're going to see three terms. You could take the square root of the first term, the square root of the last term, and then the second sign will be plus. The first sign doesn't matter. And then when you do your factoring, they're going to be identical. So when you're doing a difference of two squares, they're going to be conjugates when I factor. But when I do a perfect square, the parentheses are going to be identical. So if you can identify a perfect square, you can skip a lot of steps. But if not, you can still apply the master product method and find out what your answer is. So right here, this is a perfect square. And the reason I know this is because I can take the square root of 9x squared. I can take the square root of 4 and this addition right here. This sign doesn't matter. So because I know that, we're going to just do some shortcuts. The square root of 9x squared is 3x. And the square root of 4 is 2. And then the signs are going to both be subtraction. When the last sign is plus, you write the first sign twice. Now, my base is 3x minus 2, and it's squared. And that's my final answer. So if you can identify it as a perfect square, then you can skip all these methods and just work it out. On 67, you can also do the master product method, and you will still come up with the exact same answer. Now, if you look at your other problems like number 69, 71, 68, you'll notice that the first sign is positive. Again, that doesn't matter. So let's try 68 right quick. I have 9x squared plus 6x plus 1. It is a perfect trinomial. Square root of 9x squared I can take. Square root of 1 I can take, and it's addition in the middle. Addition on the second term. Square root of 9x squared is 3x. Square root of 1 is 1. And you follow the first sign. So I have 3x plus 1 squared, and that is my answer. Okay, so I do want you to try one. I want to challenge you a little bit. Try number 81 and see how you do. Tell me what that answer would be. And then you can check it in the back of the book to confirm your answer. Try 81. Let's look at one more for this section and we'll be finished. We're going to look at number 79. And I'm only going to do part of 79. And I want you to finish it up. So I don't want to do part of it. First of all, what's the problem here? Well, it's not in standard form. What's another problem you see? I see that my leading coefficient is negative. And while we're at it, let's make sure we don't have a GCF. Okay, we don't have anything in common, so it doesn't have a GCF. But it's not in standard form, so I want to do a rewrite. And I want to factor out the negative. So again, when I factor out a negative, all the signs change. So this becomes positive 12y squared. This becomes negative 25y. And this becomes positive 12. Okay, so from here, you can multiply these two and apply your master product method and solve and work down this problem, factor this problem. Okay, very, very important. So if you look in chapter 5, we're going to be solving too. So we have to know how to factor and then have to solve for x and y and whatever. So very important that you understand the factoring. So far we have talked about greatest common factor, factoring the difference of two squares, factor by grouping when we see 4 terms and 6 terms. We talked about factoring trinomials when the leading coefficient is positive 1, factoring trinomials when the leading coefficient is not 1, and we talked about prime factors, and we also talked about factoring perfect trinomials. So we have talked about all these different strategies so far. So please study the factoring because it's a lot of things on factoring, and we are going to build up some more on our different factoring methods. So please study. Any questions? Let me know.